few minutes and then I'll let you guys go. So, for people that are gone, we're mainly going to work on homework, so this video is going to end up short. The homework is going to be spread out over 2 days at least. This is the entire assignment. So chunk it. Do like 78 to 85 or whatever you want to do, and then do the rest another time. Or if you're motivated, do the whole thing. I don't really care. So we're going to talk about average rate of change here. Specifically using projectile motion because that's where it really matters. So I have for you here a graph that we're going to be using for Jen's lunch. And I don't think this gets used till the next problem, but you might as well have the visual before we dive into things. Wonderful. If we talk about speed, or rate, more so, because rate's a better word to use than speed, what are we talking about? Not her lunch, it's her lunch.
Oh, okay.
I wish it was her lunch, then I could have it.
I lost my lunch.
I threw my lunch up in the air.
Yes.
It's the lunch.
No, trust me, it was not good. Wednesday was not a good day.
Still.
So, we're not talking about Jen yet. We're talking about Maggie. Right? So Maggie gives us this table. Grab a calculator. Drafting calculator.
Hey, we only have five, so cool, and you check if you all have her too.
Go ahead and put Maggie's data into your table.
Table. I forgot about TV.
I didn't want to access the table again.
And if you don't remember, play around with it till you figure it out. Because at this rate, we're close enough to the test. I need you guys to be able to poke around the calculators till you figure it out.
Also, I was wondering, are we ever going to have to do an end of course exam for this
Yes.
class? Okay.
Yep.
Well,
Your table is your list, right? Your lists are your tables. You're trying to edit your lists.
we're not talking about table set, are we?
No, but we will be in a minute once we get it in the table. You want to go to the stat button column. You want to go to the stat button.
Okay.
Then go edit.
Hi.
Oh, okay.
Calculator button.
Oh, it's satisfying.
It's great.
Calculator button.
No.
Dog.
Oh no, I put that on for that.
Dog. Yeah, I do.
Then when you go to graph it, you're going to need to change your window.
Oh. Where is it?
It is a
I did it. Now I turned plot on. I need to look at plot on. Yeah, I need plot on.
the X goes with the Y.
Oh, there we go. Somebody defined the.
Okay.
Okay, so you have the listing. Now you're gonna want to change your window. So your window is. Yeah, so remember, those are your. So basically, that's the lowest your X could be, that's the highest and so on. I made it so that it looks like this.
So then,
Where's
we
my
go
window?
operated window.
Yes.
Probably
So you should okay, Jenny, look at the time as the X line and then make the dimensions based around that.
Maybe like times.
Whoa. Next one down. Y scale. So everything.
That's the minimum.
You guys modifying your window?
Got it.
Okay. Yeah, okay. I go from -10 to +10, -10 to 100 through the Y. You always want to show a little bit of the negative just so that you can see the axis.
I know.
All right.
Man, I'm not sure if my camera will agree with me today or not.
Where is
You should be able to get a graph out of this.
It's called y equals.
Oh, if there's a y equals in there, clear it. So go to your y equals menu and clear it if there is one.
Doesn't happen with mine.
So you should have gone to stat. You should have edited. You should have this list. You should have then gone second stat plot, turned on your plot. I would, if I was you, connect it using the second graphing option here, and either do boxes or T's. You do T's on it if you want, because that kind of looks good for the problem. And then if you go to graph it, you'll see your points drop down.
I hate my date or something. Mine looks a lot wider.
So then, if we want to figure out the equation of this parabola, which I don't even think that's what the question asks, but because we're doing things in here, yeah, we're going to go ahead and do this. How could I get my calculator to give me the equation of these points? When I want my calculator to do things for me, I often go to math, but that is not the case here since we're working in the table. What menu should I go look at? How do I get here?
You do stat.
Stat over to calc. Now, what do you think is important in this list? What sort of graph have we made? Quadratic, right? Go to quadratic regression, select list 1, list 2. You should really be able to enter all your way down through and then hit calculate. And it is going to spit out the equation of your parabola.
I remember doing that. What?
Now, your r squared is,
I don't have r squared.
yeah, that's dependent on whether your calculator has the residual turned on or not. That is telling us that's the correlation coefficient. Actually, r squared is your correlation coefficient. R would just be our residuals. The correlation coefficient is telling us how related the input and output are with each other. And this tells us it's very, very strong. Because, hey guys, be with me for just a moment. R squared is your correlation coefficient. It goes between -1 and +1.
So it's very.
-1 means it's very indirect, like very, as one goes up, the other one goes down. This, as one goes up, the other one goes up. But the problem is because this is quadratic, it's a bit more complex than looking at linear correlation coefficient. So we often look at linear correlation coefficient. This is slightly different. What we care about are the ABC. It does not matter that you don't have r squared. So this makes our equation -16x squared plus 76x plus almost 0, like 0.05.
So should we put that in?
Yeah, I mean, it's there, right? It's worth it. What that means is, what is this situation again? A balloon. So what that tells us is her balloon did not start on the ground, right? That y-intercept. So that balloon did not start on the ground. Questions? So now to what the problem is actually asking us to do. Average rate of change. And I'm really just going to let you guys go work on your homework, so I just wanted to cover a little bit today. When we look at a graph such as this, and we talk about rate of change, how do we figure out rate of change? How do we figure out any rate, more so? Do what?
Distance over time.
Something divided by something, right? So speed is going to be distance over time. If this is time, right, my x values is time moving forward, and this is height, my y, is my rate of change going to stay the same here as I travel? Why, when I launch something up, does rate of change not stay the same? What makes it come back down? Gravity. Gravity, right? So I don't know how to manipulate my camera. But right here is the point where gravity has won the fight, right? It slowed it down all the way up here, stopped its acceleration, and turned it around, pulling it back down to Earth. So when we discuss average rate of change, we determine the slope based off two. You know this, Ryan? If you want to teach it, you can. The opportunity's always there. Otherwise, I'm really just trying to get through this stuff fast so you guys can have time to work on homework, talk, whatever. But I keep getting distracted because you keep making side comments. So if we want to do average rate of change between 1/2 second and 1 second, you just take the data from those two parts of the table. That would be your average rate of change at that moment. But that does not tell you behavior of the entire function because it changes, right? So the average rate of change between like 1 second and 3 seconds would be very awkward because it actually has started coming back down. So that would goof us up. We should really do average up into a peak point and then back down. So I want to be able to cover this stuff when we have the whole class together. You have Jen's launch graph in front of you, but we will. Let's finish these real quick since we have all this in our calculator. So you guys can already figure this out. Velocity is almost 0. So I'm not going to make you process through each of these questions, right? So if we go and we look at these different rates of change, they get smaller and smaller, right? This one has gone up by almost 30. This one does not even go up by 20. This one barely goes up by 10. It goes up by exactly 10. This one only goes up by not even 2.1. And then we start turning around, right? So my velocity has gotten closer and closer to 0. What do you predict the velocity of the balloon will be just before it hits the ground? What do you think? The velocity of the balloon will be just before it hits the ground. If we look at our graph, like if we continue here, what do we know about parabolas that can help us out? What do you need? No. Like, because I need them next year, and I'm either going to have to buy more and replace them, and your guys' homework was to come with what you need. Yeah. So I'm sorry, but no. Yeah, that's class resource for me. And they don't work very well. Like, they should not try to use them for their really vulgar.
I just noticed that you have blue sticks instead of patterns.
My accelerator side math class was getting very upset, so I made some concessions.
Upset?
About the colors not matching them, but I told them there was nothing they could do unless they want to replace my pen tips.
Yeah, I guess.
What do we know about a parabola, guys?
Once it gets to it gets to the vertex, it goes back down in the same fashion.
Okay, which means it is what? What's that math word? Or it has a what? A blank of blank, which means it's the same on both sides of this thing.
I know what wait, what? I know what you're talking about.
There's a band called The Axis of Awesome, and this is sort of like that. God, you're killing me.
I'm sorry. I am not good with my math vocabulary. It is all my
all
fault.
Owen's fault.
It all is. It'll just be right there. I see.
No.
I mean, it's a reflection on yourself, but.
Because my screen got. Axis of symmetry. So we can anticipate that the behavior right here, right before it hits the ground, is the same as the behavior right here. Yeah. We know the velocity will be the same, just going the other direction, right down instead of up. So, using that information, should be able to get through all those things. So I think you guys could answer those questions about average rate of change just based on any given points. Yeah, let's just pick this up on Monday when we're all together. I'd rather you guys just do a little work on these practice problems. All right, people that are not in class, enjoy Kilbourne or wherever Ava is. Hasta luego.